Okay, in this video we're going to look at what we call radian measure. So radian measure is just a way of measuring an angle. So what is an angle? Well, an angle is sort of the measure between two lines. So it's kind of there. So typically, or what we're used to in terms of measuring angles is using degrees. So a degree. But the question I'm going to ask you right now is, what is a degree? Now this is kind of the way you're familiar with measuring angles. So to you, or often to students, this kind of seems like the only way to measure an angle. And what a degree is, well, if you took an angle, and let's say we drew a circle. So draw a circle all the way around. The way we came up with degrees, or the way that we measure degrees, is if we took this circle and divided it into 360 equal little spaces, then one revolution, that would be 360 degrees. So that's what a degree is. We just decided, or whoever decided, to split the circle up into 360 equal little bits, and to measure an angle, you're just going to say how many of those little bits, those little sections, make up this angle. So if you had like a quarter of a revolution, we know that that would be a quarter of those 360 little pieces, so that would be a 90-degree angle. Question you might ask is, why 360? So why 360 degrees in a circle? Because you didn't have to use 360 degrees. We could have broke the circle up into any number of little equal units. And if you think about our number system, it might have actually made sense to use a different amount of spaces, or break it down into a different amount of sort of little equal units. We use metric, so it might have made more sense to use something that was divisible by 10, so maybe like 100. So like you could have taken one circle and said, okay, I'm going to break that down into 100 little spaces. So in that case, one revolution would be 100, whatever you want to call it. A quarter of a revolution, a right angle in that case, would have been 25, or a quarter of the 100. So why did they use 360? That's not nice and, well, it's divisible by 10, but it doesn't kind of jive with our metric number system. And the reason that we use 360 is, if you think back to, or sorry, if the reason we use 360 is, it was the idea of degrees dates back to before we had a base 10 number system. It actually dates back to the Babylonian number system, which was base 60. So if you think, so what that means is they had, rather than having the numbers, like we have a base 10 number system, meaning we use the numerals 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then once we get to that one, we go to the next decimal place. We use these 10 digits. That's a base number system. Why do we have, why 10? So if you think about this, probably again, you won't spend too much time thinking about it, but that was kind of arbitrary too. We could have come up with more symbols for bigger numbers, but we decided 10 was a good number of symbols. If you want the reason for that, just take a look at your hands. You have 10 fingers, 10 toes, so that's why we use 10, a base 10 number system. But the Babylonians had what was called a base 60 number system. So basically what that means is they had 60 symbols for the first 60 numbers. And if you think about that, it makes more sense as to why you'd have 360, because 360, or 60 divides nicely into 360. So that's kind of where this idea of degrees dividing it into 360 came from. We can actually see the remnants, or this idea still in use if you think about minutes. So there's 60 minutes in an hour, 60 seconds in a minute. That again dates back to this idea of a base 60 Babylonian number system. So anyways, we could have divided it into something else, but we chose not to. We chose 360, or someone chose 360. Um, Now, in mathematics, we don't love that. We don't like the fact that that's an arbitrary thing to divide into, right? The fact that it could have been 100, we could have divided into something else. Um, there's sort of an arbitrariness to that. So we have another way of measuring an angle, which doesn't involve dividing a circle into any amount of pieces. The way we're going to measure it is, again, let's consider a circle here with an angle. So I'm going to call the radius r, and this measurement along the circle, which is, we say, subtended by the angle, so it's like the part of the circle that's kind of covered by the angle, we're going to call that A. So A is equal to what we call the arc length. So the bigger the angle, sort of the more arc length you have, and r is the radius. Okay, so now we're going to measure theta as just the ratio of these two lengths. So theta is equal to A over r. And this is how you measure a radian. So that's all that that a radian measure is. It's just a ratio of these two sides. And for any given value of theta, this ratio is always going to be true. So sometimes people say, well, what if the circle was bigger or smaller? So imagine you had a bigger circle. So if you extended the circle, then the radius is obviously going to change, right? The radius would become longer, but notice so would the arc length, right? So you'd have a bigger arc length because it would be part of a bigger circle, and it would all be proportional, right? These are similar shapes, not similar triangles because it's a curve here, but kind of similar concept. It would still be proportional, so your ratio of A over R is always going to be constant given your value of theta. So that's why this becomes a good way to measure an angle. So that is what a radian is.